Hi, everyone. Thank you for joining us today. My name is Ben, and I'm the founder and president of ROOMSYS. ROOMSYS is a centralized and remote smart building solution. Today, we'll show you how ROOMSYS can transform the way you monitor, control, and operate your building or properties. Here's an overview of what we'll cover. First, we're going to go over common challenges that property managers and building operators face, the way that ROOMSYS addresses them. Then we'll go through a demo of our solution and showing you exactly how it works and how it can integrate seamlessly into your operations. Afterwards, we'll wrap up with the Q&A session. Okay, so let's talk about some of the challenges that building operators and property managers face. The first is high maintenance and repair costs, particularly when it comes to water leaks. When you have a building with hundreds of valves or a portfolio of hundreds of properties, manually inspecting them and responding to leaks requires a lot of human resources. These resources are typically not being utilized efficiently when they have to go door to door to identify the source of a leak. Meanwhile, as the leaks are continuing, this additional damage and expenses are occurring in the building. One of the features of our system is that we can install thousands of leak sensors throughout a building or throughout a group of properties, and they will let the managers know exactly where a leak is occurring so that they could respond promptly to it. Another problem that building operators and property managers are facing is increased electric and water and other utility expenses. Sometimes you have a situation where a tenant might turn his HVAC on to the highest setting and then leave, in which case the AC is running all night while there's nobody in the building or in the office or whatever the rented space is. So what our value proposition is to give you real-time insight into what's happening in your building or in your group of properties, and not only to see what's happening remotely, but to be able to respond remotely by sending commands to different devices, turning them on or off. Also, we can set up different kinds of automations that won't require human intervention. Um, so let me go ahead and show you some screens, and we'll go into the demo part now. So here we have a dashboard with the live video stream on the bottom half. You have a floor plan of an apartment. Above that floor plan, you have the sensor readings from a 9-in-1 air quality sensor. So starting from the top left, it has carbon dioxide. Moving right, you have ozone levels, particulates from 2.5 and 10 micron, barometric pressure, temperature, humidity, total volatile organic compounds, and light level. So as you can see, these readings are coming in from the device on the bottom left part of the video. So concept is you can monitor air quality conditions based on these readings. You can set up automations to either air purifiers or dehumidifiers, or if we're talking about light levels, you can automate like blinds and shades, motorized blinds and shades to open or close according to those levels. Moving to the right of the screen, we have a widget of a thermostat. That thermostat is on the bottom right of the video. So, for example, I can set the temperature to 76 in the dashboard, and as you see, it changed the temperature to 76 on the device. What else we can do? We can turn the device off entirely. As you see, all these numbers from the bottom just disappeared. We can turn the device back on. We can change its mode. Now the device is on, so the bottom right here, this is the fan mode, so we'll go from circulate to auto. As you see, the text just jumped up to auto. Another example some of the devices we have. We have a motorized water valve. So the scenario would be, this is one of the leak sensors. I have a wet towel. So I put the towel back with the sensors. We have a leak alarm going automation that we created where the light is flashing red when the leak alarm starts and changes to blue when the leak stops, as well as the alert stops at the same time. So that's just an example of one type of automation. When the leak sensor goes off, we make the light flash either red or whatever color you want it to be. When the leak alarm stops, we send the command to the light to change to blue. So conceptually, this type of automatic command execution can be done with any type of sensor and any type of device. So if your use case is air quality monitoring to improve air quality based on the particulate readings or carbon dioxide readings, we could increase airflow based on that. Um, Additionally, there are devices that are not shown on the screen that we can integrate, such as light switches. So you can automate all of the lighting control in your building. You can even connect it to presence sensors, motion sensors. We can even actually take your existing cameras. We can add AI functionality on top of them so that they can recognize human motion detection, um, face identification, or license plate identification. And then based on these recognitions, you can send alerts, you can trigger doors to open or garage doors to open. There's really a lot of possibilities. It varies based on each customer's needs, and that's like one of the other kind of strong points of our system is that we can fully customize the alerts and the automations based on your particular use case, based on your particular pain points, because we've seen that it varies a lot from building to building, operator to operator. Um, what else I'd like to show you is how we can visualize a set of properties in one screen. So if you're managing multiple properties, you can click on any one of these. They open up another dashboard. Inside this dashboard, you have your different tenants. You can click on each one of these tenants and it will take you to their office space and show you different metrics based on the sensors that they have installed. Also, we can visualize buildings this way, where each one of these boxes is an apartment. And you can click on any one of them and we'll open up an individual dashboard for that particular apartment with its actual floor plan. So we digitize floor plans so that you can see what's going on without any really training of personnel. It's very intuitive to just open it and see what's happening and understand that you can click and move things around as you would expect them to move naturally. So here we have some metrics, particulates, and here we have energy consumption. So this is a pretty popular use case, energy metering, which is something we didn't even discuss yet. As far as sensors and devices that we can integrate, energy meters, gas meters, water meters, switches. So this is actually one example. This is a Wi-Fi Bluetooth device. It's a 3-phase switch that we can use to like retrofit basically different types of devices, say like water heaters and water pumps that are already installed but don't have a way to remotely shut them on or off. We can also create like automations with these types of switches to turn on different devices at certain times. We can go even further and using presence sensors, motion detectors, and AI cameras. You can also trigger lights and switches to turn on and off based on different detections. Um, s- so I think this is pretty much everything we have to show for today. At this point, I think we can move into the Q&A session where I can go over some specific questions that you may have, as I'm sure I did not address everything in this presentation. So let's go ahead and take some questions now.
So the first question we have is from a YouTube viewer. How complex is the installation and adaptation process for older buildings? How long does it take to deploy the system in an existing building? So one of the strengths of our system is that we can use either Wi-Fi, Ethernet, or even cell phone signal to get your building connected. We use LoRaWAN primarily for large installations, although we're not limited to just LoRaWAN. We could, like I showed, use Wi-Fi devices or Zigbee devices as well. But because LoRaWAN is a wireless protocol, we can get a building, say with like 130 apartments, fairly large apartments. We can get, say, like a couple thousand leak sensors in there in about a 4-week period from the date of delivery of the equipment. We need about maybe 2 weeks to label, provision, map them, assign them to the right locations, and then about another couple of weeks to go through and place them. So when it comes to something like water leak sensors, which are completely wireless, it's a pretty fast and easy process to retrofit a building. There are other devices like thermostats and light switches and say water shutoff valves that require a little bit additional work installing them because they're wired. One, like in the case of thermostats, it would need to be connected to your HVAC, or if it's a shutoff valve, we'd need a plumber to come in and to cut the pipe and install it. So it varies in general. If we're talking about leak sensors and wireless devices, battery powered devices like door open sensors, it can be extremely fast. If we're installing other devices like shutoff valves or water meters, or then the process is a little bit more extended. But generally, the point is that we can retrofit a building that once the walls are already up. Okay, so let's take another question. So we have a question about how can ROOMSYS help property managers improve their Energy Star rating or comply with green building certifications? So as I mentioned, energy use, energy metering, it's a pretty popular use case from two perspectives. One is to save costs, save money on costs on energy usage by being able to see what lights are on and off, the settings on thermostats, whether they're set too high. You can combine some of these things with occupancy sensors and create automations. Like if the building has no people in it, then all of the thermostats should go to a certain setting, temperature setting. When it comes to Energy Star, it's if the first thing you need to do is put like meters in place in order to understand like what your usage is. From there, you can get a rating based on that data. In Europe and in other parts of the world, I know Australia, they have also energy net zero mandates where buildings need to monitor their usage in order to become compliant. So these are all things that we're able to do. We even have a tool that can predict your future usage based on your current usage. So yeah, that's a lot. There's quite a few things we can do with the monitoring energy and giving you data on that. Let's take another question. We have Andrano from LinkedIn. For the LoRaWAN devices, where are they placed? How is the transmitter and receiver configuration? How is the reliability? So LoRaWAN is quite reliable. You'll usually have enough gateways installed in a building so that there's redundancy. I mean, the way it works with LoRaWAN, the gateways are listening for the signals from the sensors. So if a signal from a sensor can reach multiple gateway antennas, then you have this redundancy in the system. Now, where they're placed, the gateways, it depends on the building. It depends on how it was wired, what their connectivity situation is, and it varies from building to building. Also, the penetration of the signal through the walls varies from building to building. So there is some element of a sidewalk that sometimes needs to occur, but on the other hand, the gateways are relatively inexpensive, maybe a few $100s, depending on whether they're Wi-Fi only or Ethernet only, or whether if they have GSM, Ether, and Wi-Fi, then it's going to be a little bit more expensive. But with the redundancy of the gateways, I mean, obviously Ethernet is the most stable connection, but some buildings weren't wired for that. And so just as a matter of cost effectiveness, if you have a strong GSM signal, then you can rely on that. If we're talking about where the sensors are placed, well, if they're leak sensors, they're going to go behind the toilets, in HVAC closets, underneath refrigerators and dishwashers. We have a customer where each apartment had between 15 and 25 sensors to go into every possible leak location, like every valve of every sink, toilet, in the kitchen as well, and laundry machines and stuff like that. All right, let's take another question. So we have a question about AI functionality. So you mentioned AI-powered features like face recognition and motion detection. How does ROOMSYS ensure data security and compliance with privacy regulations, especially in multi-tenant buildings? So when it comes to personal data, everything obviously in our system is encrypted, and we have encrypted password protection. But our platform is designed on Kubernetes. It's based on Kubernetes, so that gives us a lot of flexibility in how we deploy it. So we have our own servers, our own cloud. We have one in the United States and one in Europe. So we are GDPR compliant. We do handle data very carefully, but there are also circumstances where for particular customers, they want to control the data themselves. And so because of our system, our platform is built on Kubernetes, we can deploy it in any cloud, in any server environment. We can even deploy it like on-prem if the customer purchases their own hardware, servers, things like that. So we have a question from Martin from LinkedIn. He asks, hello, if the utilities, water, gas, electric, place a single metering device for the whole building, can you determine how much is used at each apartment? No. So you need to have more meters to understand what each individual apartment's usage is. So that's sometimes they have kind of devices that have meters installed. So there's actually these smart plugs. They basically look like a regular electrical outlet, but they have a LoRaWAN functionality. You can send the command to turn them on or off. And those smart plugs also tell you the usage. So if you install the smart plugs, then you will actually have many meters all over the building. But if the building is already up, well, you would need to install meters in various locations to get a better kind of granular data. Let's see, another question. Can you, Maria from YouTube, can you share examples of successful implementations and ROIs? So yeah, I mean, one of our main use cases was relating to water leak damage. We had a client that put in $1 million in insurance claims in 1 year. And every 2 to 4 weeks, they were having a major leak event. It was a high-rise luxury building, and the situation was like leak would start, and it might go through 5 or 10 floors before somebody saw it coming through their ceiling or whatever, and then the staff of the building would need to go door to door, knocking on everybody's door. They weren't even sure what floor the leak was coming from. So, like with our system, since we installed, they have had zero insurance claims. They catch leaks like within minutes of what they know exactly where to go. So, when it comes to leak detection, like the ROI can be like practically instant. Before we even finished installing, we were catching leaks in HVAC units. So that's just one example with leak detection. Another is with like lights and thermostats that we installed in an office building. They're able to create a schedule of when the light should turn on and off. They also created limitations on the thermostat settings. So, like a tenant couldn't set it below a certain temperature or above a certain temperature. And then also during certain times, the thermostats would be programmed to, like when the building's unoccupied, say after 8 p.m. or 10 p.m., like set the temperature higher so that the AC stops running. And they were able to get a reduction, a pretty significant reduction in their monthly energy bill. Okay, we have a question from Julian. What type of sensors and devices does your system support? So our solution's based on a IoT platform. So we're completely hardware and protocol agnostic, meaning we can connect sensors and devices from any manufacturer using any protocol. It could be Wi-Fi, GSM, it could be Bluetooth, Zigbee. We even support wired protocols like Modbus. We have even ways to convert Modbus into LoRaWAN to give you remote functionality, remote access to your building, even if so you can have an existing system in place, and we can kind of give you remote command and control functionality of that. It really varies. We prefer LoRaWAN. It has a lot of benefits, especially for large installations. We have integrated a lot of LoRaWAN devices, but in a case-by-case basis, our goal is to solve issues, solve problems, and bring value to the customer. So we're always looking for the best device in terms of quality, in terms of performance, but at the same time, we're trying to lower costs on the devices and find the most cost-efficient solution as well. In some cases, if it might mean, like I showed the Shelly electrical switch, like there's a particular use case where the building has really strong Wi-Fi. It's a commercial building, so the Wi-Fi is managed by the building owner, and it was just the best solution for what we needed. We had a 3-phase water heater, so that already limited the types of switches that we can use. And it was 32 amp, I believe. So we also needed to have a switch that can support that as well. And so based on what we found, we used the Shelly. But yeah, it varies case by case. We have a lot of flexibility with the devices that we can support. Okay, we have a question from Andrano. Does ROOMSYS provide automatic conditioning of AC based on how many people are inside the room? For example, when there's only one person left, it doesn't make sense to keep the AC working. Yeah, so that's one of the things that we can do is like we can create automations based on different rules. So you can combine. So if you have occupancy sensors for one, right? The occupancy sensor tells you there's one person left in the room. Based on that reading, we can automate a command, turn off the AC or set the AC to a different temperature. You can do the same thing with like AI cameras. If you have an AI camera that's detecting the number of people in the room, when the number goes below a certain threshold, you can send the command. But we can also we're talking now about sending commands to ACs, but in general, we can send commands by using a combination of metrics or a combination of readings. So, for example, say you have a door open sensor and you open the door, and so now you know the door is open, but maybe you want to get a different reading too. Maybe you want the door to be open and the humidity sensor to go above a certain threshold. And then when those two things occur, only then do we send a command to the dehumidifier or whatever. You can have different devices connected to smart switches, and so you can send commands based on different combinations of scenarios happening. So we have a question from Nassim. Do you use intelligent digital twins along with NLP feature to enable all stakeholders, including laymen, to communicate with your platform? So I'm not 100% sure what you mean. I understand. So digital twins could be in a few different ways, represented in a few different ways. We don't have like a type of augmented reality, although I've seen something like this where you can basically digitize the actual room and every element inside that room, for example, like a light switch or electrical outlet, and you can represent that outlet in this virtual 3D representation. We haven't gone so far into that type of augmented reality. We digitize floor plans that we're given or that we can find online. In the case of condominiums, there's like sales offices that publish all of these floor plans. But we do digitize the floor plans, and we do place the icons or some visualization of the devices in the floor plan, with the purpose being that the operators, the engineers of the building, the laymen or whatever, they can just look at the screen, they can look at the floor plan, and they know exactly what device they need to go to and where it's located. We have color coding, so like green circles mean that there's no everything is good. Like flashing red means there's alarms. So we've tried to make the system as intuitive and easy to use as possible. Okay, we have a question from Nestor from LinkedIn. How are the sensors powered? For example, leakage sensors. So they're powered on battery. Different sensors from different manufacturers use different batteries. Most of them are on AAA. Some sensors, see if I have one, like this one, this rope sensor from Tektelic. So the battery and antenna are inside this box. It's a quite small box compared to this one that holds the. So this is everything is in this box, including the sensor part, the prongs. Here you have the rope. That's like the sensor part that when this gets wet, it sends an alarm. But inside here you have like a coin battery. I don't know exactly the code of it, but generally with the leak sensors, they're battery powered. This is why we use LoRaWAN, because these sensors, they're basically in a deep sleep mode when they're not in contact with water. They also have a health check interval that can be programmed. We set them to 6 hours. It could be 12 hours. It could be 24 hours. It could be less. These devices are rated to last for 5 years, and we've done some tests to see what the maximum number of messages a device can send, and did some calculations. And basically, figured that even with every 6 hours with the health interval check, these devices are going to last for 5 years under normal usage. And so these are Class A LoRaWAN devices, so they're like in deep sleep mode most of the time. But the other devices that I showed, like the thermostat, the shutoff valve, and the light, those are powered they have either USB-C or some kind of other power connection. And so those devices work on LoRaWAN Class C, meaning they're all the time available to receive and send messages. Whereas with the leak sensors, uh, they'll send messages whenever they get wet. But if you want to say remotely change the configuration, it'll only be available, it'll only hear your command during the health interval. So with Class A, you have to wait until the health check interval in order to say change a configuration. But it's not something that's really needs to be done that often with the leak sensors. It's more about like with the thermostats, with the shutoff valves, they need to accept the command immediately. Light switches too. So, yeah. Nassim, does your system provide real-time access through QR for each individual? If someone from FM is on site and would like to access the parametric data through scanning of QR. So the QR codes on the devices just pretty much store their like EUI app and device codes, which are how you connect them to a LoRaWAN server. So the QR is more for the provisioning when you're getting the system set up. As far as getting device data, all of the data is published um, first in the TTN. Well, in the LoRaWAN server, we use TTN, although there's ChirpStack and other LoRaWAN servers. We integrate all the data from the LoRaWAN server into our platform. So the data from the device is readily available. It's stored. We store alarms. The data, we understand, is important sometimes for different reasons. It could be like for your insurance company to give you discounts, but then there's also I know a whole industry about data from real estate getting data from real estate in order to provide better valuations on properties and things like that. So yeah, for sure, one of the benefits of this type of system is that you have all the data and you have access to all the data remotely. All right, thank you very much. I think that's all the questions we have for today. If you have any other questions, please feel free to reach out to us. You can visit our website at roomsys.com. We have a contact us form, or you can contact us on LinkedIn. So thank you for your attention and thank you for joining, and have a wonderful day.